Okay, so kidney, um, the proximal tubule is the first thing all that filtrate enters right after it enters that Bowman's capsule. And there's a lot of good stuff in there. Your body needs to start getting it back. So, you gotta get it back into the blood somehow. And most of this reabsorption occurs in the proximal convoluted tubule. And this is our abbreviation, thankfully. um, Almost all of the glucose, amino acids, and about 80% of the water, minerals, and sodium have been reabsorbed. So, seems like a waste of time. Just got removed from your body. Now your body gets it back. That's the way the body is. Somehow it just evolved to be better that way. All right, so check it out. This is what we got in this proximal convoluted tubule. Sodium ions need to move by active transport. So protein, if you see a protein pump, that's active. It's definitely using ATP. And then move back into the capillaries that surround the tubule. You have a lot of blood vessels, capillaries surrounding these tubules that are ready to reabsorb all these very important molecules. Chloride ions are pulled out of the filtered blood. Let's see, there we go. Into the capillaries due to the charge on the sodium. Okay, so they attract. So check it out. So the sodium, which is positive, starts to move. So then chloride kind of joins onto it. Okay, and since it's attracted and it moves along with the sodium, and glucose moves back in to the blood using energy from active transport, and then sodium ions help to pull on the glucose via co-transport. Okay, so as the sodium is being pulled out, it's also pulling glucose with it. So you spend some energy on the sodium, okay, using that ATP, you get a bonus. You get to pull out the chloride with it and the glucose get to move along. Chloride with the charge, glucose with the co-transport. Kind of fits in together. And water, as we know, the way it moves, osmosis, and moves toward areas that have a high solute concentration, like the loop of Henle. So wherever it's really salty, really sugary, water is going to want to move toward that area. So the loop of Henle, it's that long, you got Bowman's capsule here, and you got the proximal tubule, boom, you get this little loop here, and then doom, doom, and this is the loop of Henle, and it creates a gradient of solute, so it gets more concentrated as you move down that loop of Henle. And cells in the ascending limb, so limb, loop of Henle is like this. This is the descending limb. This is the ascending limb. And this ascending limb here is the only place where water cannot leave the filtrate. It's impermeable to water. Makes it very interesting. As the filtrate moves down, your P, soon to be P, becomes more and more concentrated. And then it gets less concentrated, it moves up because salt or sodium is going to start to leave. So your water content stays the same, but you have a lot less sodium there. So it's going to become more hypertonic relative. So this is a nice little diagram, pretty detailed. Blood comes in here, afferent and efferent. You see how this is thicker than here. So we get a high pressure situation. And this is where we have all the stuff that came out of the blood. And urea is going to stay in here. You have the arrow. But look, getting out of there is glucose, ions like sodium and chloride, water, and AA. You know that to be amino acids. And then you see 400, 600, 1200 getting more concentrated. But as we go up, look at these numbers. Less and less concentrated as the sodium leaves. But remember here, water cannot get out the ascending limb. And then we go in the collecting duct here. Becomes, again, we're going deeper in the medulla. And this is becoming a bigger gradient. So more concentrated. It's pulling out water from the collecting duct right there. And the longer, say, we would have a loop of Henle about like that, a desert animal like a kangaroo rat would have a longer one. And say a rainforest animal like a chimpanzee would be smaller than ours. Anything living where there's a lot of water. But actually, it might be pretty similar since we're descending, but maybe something further away from us. The longer the more water can be reclaimed. And going down, descending the loop. I think that was the word I was looking for. Yeah, going down. The fluid outside is getting higher, and that's pulling more water out. So the longer the loop, it's going to be more like good for a desert mammal. Okay, have long, thick medullas and long loop of Henle's. Okay, so hypertonic, hypotonic, we got to review that. Hypertonic, that's higher concentration. Get hyped up, that's hyper, think of high. Oh, this is hypotonic, so yeah, fix that. They have a lower concentration. Okay, isotonic, that's an equal. So there's no difference. And the fluid coming out of the distal convoluted tubule is the proximal loop of Henle distal. It's higher compared to the rest of the body. Okay. Sorry, it's not higher. It is hypotonic. Because remember, going up that loop of Henle, the water was coming out. The water was not coming out. It was staying in. The salt was coming out. So it's becoming less concentrated. Okay. If the solute concentration in the blood is too high, or too, is low, meaning there's not a whole lot of salt there, little water is removed. And urine is light yellow, and is light yellow, it is very large volume. So you're not struggling for water, you got plenty. Your body's not going to remove much. However, if it's too high, this part of your brain, it's a gland, hypothalamus, tells the pituitary, which is also in the brain right below, to release ADH. Okay, antidiuretic hormone. And that makes the collecting duct walls more permeable, okay, to water. And ADH decreases the volume of urine and becomes darker yellow, so more concentrated. And this helps your body maintain balance, which fancy word, homeostasis. And this regulation of water has this fancy word, osmoregulation. Okay, so osmoregulation is a balancing act your kidney is responsible for. And here you should try to get something similar to this. 494, you have this diagram. But low ADH, you see these numbers, concentration numbers 125, 150, 175. This water is going to stay in here, okay? But this water is remaining in there and keeping that concentration pretty low. But here, your body senses needs water, it's going to be pulling water out like crazy. And look what that does to the concentration. It raises it quite significantly. So nitrogenous waste, let's get on to that. Ammonia. And this is a lot based on evolutionary history and where an organism lives. But we make ammonia, and you've all smelled that before when your body breaks down amino acids and nucleic acids. You get this ammonia left over, and not good for your body, toxic. So you got to either remove it, like we talked the other day, fishes can remove it very easily, or you need to convert it to something that's not as dangerous. So terrestrial organisms use energy. Fish don't have to use energy, just get rid of it, but we need to convert that into urea or uric acid. And birds do uric acid, like we talked the other day, they make that white paste. Since it is insoluble, and remember, it does not mix with, that's what insoluble is, does not mix with water. It will not harm a chick when it's developing in an egg. I can't see that word. An embryo, this might be embryo, when it's developing in an egg. And a big bonus, for birds especially, it's lighter since it doesn't have that water weight, and it helps birds fly. I don't know if that's written in there or not, but it helps birds fly. And here we go, nice little, remember we talked about proteins and our nucleic acids making these nitrogenous wastes, and fishes, ammonia goes right out the gills here, no sweat. Mammals, we convert it to urea and pee it out, and birds and some reptiles convert it to uric acid. So drinking too much water, not enough, both are problems. So if you're dehydrated, you might be sleepy, or say sleepiness. You also might be constipated. Yes, so watch out. That's pretty common. Kids or people are constipated, they're not drinking enough water. Dry mouth, your skin is dry, dizziness, and headache. All sign of dehydration. If you're overhydrated, your behavior might change, and you might be confused. You might have blurred vision, and muscle cramps, which also could happen in your dehydrated state too. And nausea. I don't know if you can read that. I'll write it over here. N-A-U-S-E-A. Okay, nausea and vomiting.